Today we're going to be working with square roots and also with squared terms and equations. There are some very famous formulas that deal with square roots and squared terms and equations. And I think anyone who considers themselves educated should feel comfortable in working with such equations. Now, before I even go into anything further here, I want to preface what I'm going to say is that we're just going to barely scratch the surface of solving equations with squared terms. A squared term, you may remember from your high school math days, that if you have a squared term in an equation, you're going to end up getting a shape that looks like a parabola. Okay, if any of you remember that, you'll get a shape of a parabola, a nice smooth curve when you have a squared term in an equation. Parabolas are extremely useful. Anyone that has ever had a very good, strong flashlight that beams a beautiful, strong, powerful beam probably had a reflective surface behind the light source that was in the shape of a parabola. There are many, many places where parabolas are used in industry. There's a very famous one in the country of Morocco where they took acres and acres and built a solar electricity generating system based on parabolic structures. So it's just an amazing thing when you have a squared term in an equation. Now, we're only going to work with some simple squared terms. I just want to give you a feel for how you work with equations with squared terms in, and then we'll also do some with square roots, okay? So just keep that in the back of your mind. We are just barely scratching the surface here as far as squared terms and whatnot when we're solving. All right, so in other words, right here, problem number one, we have some number times itself is 36. Well, everybody knows right away the answer has got to be 6. Yeah? But it could be -6 also, because -6 times -6 is also 36. Okay? So when you have a squared term equal to something, okay, you want the square roots, plural. We want the square roots. We want the positive square root and the negative square root, so it would be 6 or -6 for that particular answer, okay? Now over here in this particular problem, it would make sense, just like when you solve a simple equation, you try to get x by itself, it would make sense in this problem to try to get x squared by itself. So we're going to add 17 to both sides. So I have x squared minus 17 equals 289. If I add 17, I get 306. 17 looks like 306. So I want the square roots of 306, and I get 17.49 plus or minus, okay? 17.49. How about the third one? I would think I would want to subtract 200 from both sides to get x squared by itself. If I subtract 200 from 74, I'm going to get a -126, I think. 74 minus 200. Yes, -126. And you can't take the square root of a negative. Nothing times itself is going to give you -126, at least not in the real number system, which is what we're going to be working with, okay? So there is no answer to this particular problem. How about number 4? We want to try to get the squared term by itself. Now this one is a little tricky, because you've got a number of things you need to get rid of. You need to get rid of a 24 and a -3 before you can even think about taking square roots, okay? So what I would do in this problem, I think I mentioned this when we first started solving equations, I would add the 3x squared over to the right-hand side, and subtract the 12 from both sides. So I'm going to add the 3x squared over here and subtract 12, and I get 12. Okay? Now you have no negative signs to worry about. So divide both sides by 3, and I get x squared is 4. So x could be plus or minus 2. Correct? Okay? Okay, the middle one right here, you could take the 2 into both parts. That's fine. Okay, and you can work it out from there. 2x squared plus 14 equals 34. Subtract 14. 2x squared is 20. Divide by 2. X squared is 10. And you want to know what times itself will give you 10. And it should be 3.16 plus or minus 3.16. The other way you could have done this problem would be divide 2 into both sides right away. The 2 goes away. You have 17 over here, subtract 7, you have x squared equals 10. Kind of the same thing, just smaller numbers. So over in number 6, the last one there, 5 plus x squared divided by 3 is equal to 20. I would cross multiply. Anytime you have a fraction equal to a fraction, cross multiply. I get 5 plus x squared times 1 is just 5 plus x squared. And 3 times 20 is 60. Subtract 5 from both sides is 55. And you want the square roots, the positive and the negative, of 55. And I get 7.42. So x is plus or minus 7.42. Now, so to summarize, when you're working with a squared term, it makes a lot of sense to try to get the squared term by itself, okay? You've got to be careful, especially when you have problems like this one here. Remember, we got the squared term equal to a negative, and you can't square a number and get a negative. So you're not going to have an answer occasionally. That might happen, all right? But most of the time, if you get the squared term by itself, as we did in all of these problems, you can then get the square roots, the positive square root or the negative square root. So you're probably, in most cases, going to have 2 answers or no answer at all for these problems. All right. Now, let's talk about square roots. Square roots. If you have a square root in a problem, like right here, number 7, the square root of x is equal to 9. Square root of some number is 9. Square root of 81 is 9. So x would have to be 81 here, okay? And you can only take square root of a positive number. Look at number 8. Just as we tried to get the squared term by itself in the first 6 problems, in number 8, wouldn't it make sense to get the square root term by itself? So divide by 3, and the square root of x is 5. Okay, so the square root of some number is 5, and I think we should all know that that is 25. It's not 25 or negative 25. You can't do the square root of a negative number because 5 times 5 is not negative 25. Okay, so the number is just 25 as your answer to the problem. How about number 9? The square root of x plus 5 is equal to 20. You already have the square root by itself, okay? So the square root of something is 20, all right? So now this gets a little trickier. So let's go back up here and once again look at this problem. Then we're going to come down and talk about this one. In some of these harder ones down here, you may struggle a bit with some of those. So let's go back and think of a different way. Like right here, when I said the square root of some number is 5, everybody knows it's 25. But down here, that's a little trickier to figure out. So let's talk another way you can look at the square root of x is 5. If you want to get rid of a square root, you can simply square both sides. Okay, so I'm going to square both sides. It gets rid of the root, and 5 squared, 5 times 5 is 25. That method is really helpful in this problem. You can square both sides, okay? You get rid of the root. See, I got rid of the root, and 20 times 20 is 400. Subtract 5, and x is 395, okay? How about this one? This sign means the positive square root. This sign, this radical sign, means the positive square root. So the positive square root is never negative. Let's go back up here. Remember what I said back up here. When you wanted to find out what number times itself is 36, you want the square roots, plural, square roots. Okay, you want the positive square root, which is 6, and the negative square root, which is negative 6. This one is saying, if the positive square root is negative, it can't be. This sign means the positive one. It can't be that a positive square root is negative. There is no answer to problem 10. Okay? Let's look at 11. 11 says the square root of x minus 6 is 18. Just like this one, it would be very helpful to get the square root term by itself. So let's say it's 6. Square root of x is 24. And now, once again, you may not know the answer to this in your head, but if you think about what I just said, to get rid of a root, you can square both sides. So x has got to be 24 squared, which is 576. Okay? Number 12, the square root of x minus 2 is 8. How do you get rid of a root? Square both sides. So x minus 2, the root's gone, is 8 times 8, which is 64. Add 2, and x is 66. Okay? All right. So that is how you're going to be solving equations with square terms in or with square roots in them. Now, what is kind of cool about this, there are some really neat problems where you have square roots or square terms. All right, so let's talk about a couple. Police use the formula S equals the square root of 30FD to calculate the speed in miles per hour, which is this S, the speed, and the skid distance D in feet. Okay? The F right here, this F is a particular constant dealing with the surface, whether it's a tarred surface, a concrete surface, a gravel surface. Okay? I mean, have you ever come on the scene of an accident and seen the police officers with measuring tapes, measuring skid marks, and trying to verify what really happened in this particular accident? This is what they were doing. And there's my friend, my good old pop-up friend, yes. Okay, see if I can get rid of my good old pop-up friend. I keep saying I want no pop-ups, and that guy keeps coming back. Anyway, all right. So here's the formula we need. At the scene of an accident, there are skid marks 65 feet on wet concrete. Suppose you're the police officer. You need to calculate the speed before the brakes were applied. Okay? So our formula is S, which is the speed, is the square root of 30FD. Okay? And we know that the speed is what we're trying to find. Skid marks of 65 feet. And the 65 goes in for the letter D. Okay? We are on wet concrete. Wet concrete has a F value of 0.4. And we have the 30 here. Okay? So to find the speed, this is a relatively easy problem. I just multiply what's inside there. So I'm going to take 30 times 0.4 times 65. Okay? Get that answer. Then I want to take the square root of that answer, and I get that the speed was only about 30 miles per hour. Okay? Let me double check my work on that. Yep. It is about 28 to 30 miles per hour. Okay, depending upon how you round up. So the car wasn't driving all that fast. All right, let's look at the next one. Here's our formula. And the next one says, suppose a car is traveling at 50 miles per hour. Okay, if a car is traveling at 50 miles per hour, that is the speed. How far will it skid on wet tar? How far will it skid? 30. Wet tar is 0.5. Okay, 0.5. And we want to find the distance. All right, so we want to find out how far it's going to skid on wet tar. So 0.5 times 30 is 15. So 50 is equal to the square root of 15d. It would be very helpful to get rid of that square root sign. How do I do it? Square both sides. Okay, so if I square both sides, I get 15d is equal to 50 times 50 is 2,500. Okay, so if you are traveling at 50 miles an hour on wet tar, you are going to skid for 167 feet. Okay, 167 feet, which is what, about half of a football field, right? All right, you're going to skid. You're really flying. You hit the brakes really hard on wet tar, and you're going to slide for quite a while. All right, so very fascinating what you can do if you know how to use squared terms and square roots. A couple other formulas involving squared terms and square roots. Number 14 is if you drop a ball from the top of a 400-foot building. Its height above the ground will be h equal to this formula, t seconds later. You can figure out where the ball is as it's falling to the ground. Find the height of the ball after 2 seconds. I can put a 2 here, and for t, work this out, and find out what the height is. So I'm going to take -16 times 2 squared, which is 4, so take it times 4, and then add 400, okay? And 2 seconds later, the height of the ball is 336 feet, okay? In 2 seconds, you have fallen 64 feet, all right? 64 feet. Find the height of the ball after 10 seconds, okay? So I need to put 10 here, okay? So if I put, there, that doggone pop-up just about drives me nuts. All right. And I'm not sure what I did. Okay. Good grief. Now, try to see if I can get back here and get rid of that stupid pop-up. Okay. Find the height of the ball after 10 seconds. I'm going to put 10 in here. 10 times 10 is 100. Times 16 is 1,600. Negative 1,600 plus 400 is negative 1,200. Whoa! How can the height above the ground be a negative number? What that means is if it's a negative number, when you put 10 in, you must be below the ground, which you can't be. The height of the ball after 10 seconds is so far down, it has hit the ground. Okay, the math in this particular section here, in this problem, does not make sense because you can't be at a negative 1,200 unless you're below the ground. So the height of the ball after 10 seconds is going to be 0. It's going to be laying on the ground. It has fallen the whole way down. You follow me on that? You can't have negative distance unless you have the ball has the ability to keep going on down through the ground. How long will it be until the ball is 100 feet above the ground? All right, so if the formula, the height of the ball is to be 100 feet, we want to find the time. Okay, we want to find the time. How long would it take till the ball is at 100 feet? Okay, so let's see if we can solve this. Subtract 400 from both sides. This is a negative 300. It's a negative 16t squared. So divide 300 divided by 16. I get 18.75. The two negatives go to a positive. Is t squared. Now, we just got done doing a whole bunch of problems like this. Okay? So you'd want the positive or the negative square root of 18.75. But you can't have negative time. You can't go back in time. So you only want the positive square root, which is 4.33 seconds. You jump off the top of a 400-foot building in 4.33 seconds, you're only going to be 100 feet from the ground. You've fallen 300 feet, the length of a football field, in 4.33 seconds. Now, it would be interesting to find out how long it takes the ball to hit the ground. How long would it take the ball to hit the ground? Well, what we want to do to find out how long it takes the ball to hit the ground is when is the ball's height above the ground? 0. Okay, so I would add this over to this side. 16t squared positive is 400. So divide by 16, get your answer, and take the square root of that. And I get t squared when I divided was 25. So it only takes 5 seconds to hit the ground. Now 400 feet is pretty tall. If you've ever been in Washington, D.C., the Washington Monument's like 500 and some feet tall. 400 feet is like a 40-story building. 40 stories, okay? You jump off of a 40-story building or 400 feet high, 5 seconds you hit the ground. Whoa! Okay? 15, talk about areas of circles. It's given by the formula A is equal to pi r squared. Probably all heard that formula before. Where A is the area and R is the radius. Find the area of a circle that has a 3-inch radius. You simply put 3 for the radius. 3 times 3 is 9 times pi. And I get about 28.26 square inches. You can very easily find the area of a circle. Find the radius of a circle that has an area of 80 square inches. If this is 80, we want to find the radius. Well, wouldn't it be helpful to get the radius squared by itself? So let's divide by pi first. 80 divided by 3.14. And I get that r squared is 25.478. Lots of decimals. And now you want the positive or negative square root of that? So I need to take the square root of that, and I get 5.05 inches is the radius. Now, it's only positive because you can't have a negative radius of a circle, okay? But this equation right here does have 2 answers, the positive or negative, but we throw out the negative one because we only want the positive. All right, so we're doing, as I mentioned, we are doing problems dealing with squared terms and square root terms. Should not be too much of a problem with these, so good luck on the homework.